one moment. Let me enlarge here the display. Now we'll go to screen share. Okay, share screen. Okay, I'll go to the slideshow. Here, slides. Okay, can you see the display?
Yeah, everything is great.
Wonderful. Yes. Hello. So my name is Alex Norta. Beck told me he's been so kind to already introduce me. It's a pleasure to be present, unfortunately virtually, because well, I'm in a project meeting in Estonia. So today, first it's an hour, yeah. I have an hour time, correct?
It's about 40 minutes.
Okay, and then Q&A. All right. Yes. Yeah. So the presentation today will be about, or is about, blockchain technology for secure IoT. I was an associate professor at TalTech, and at the moment I'm running IEEE Blockchain Finland, and I'm also a research entrepreneur. So to the top left, you see the logo of my company called Damaxion. Oops. Okay, let's go back here. So yeah, so the agenda for today, which I will try to squeeze into 40 minutes, is I'll give you a very quick introduction, then a motivation why we need to look at this intersection of blockchain, IoT, and security, which has to do with the so-called machine to everything economy. Then we have a block where we try to understand the elements, Internet of Things, blockchain and security, and then step by step, we will explore the relationship between IoT, the data it generates to be secured, blockchains, and security, basically on the intersections. Then I have some application cases I can run through, and some recent research results, followed by the conclusions. Yes, so my quick introduction, Alex Norta, you will find me on LinkedIn and also on the Estonian research website called etis.ee, or you just type my name in, Alex Norta, into the internet, and you will find a lot of information about me. And I'm also on ResearchGate, where the link is provided on top. Yeah. Yeah, this we can skip, I think. I'm also editing currently a special issue on blockchain technologies and secure IoT networks. The deadline has already passed, but we have a little bit of an extension for that. So yeah, if anyone has some papers, please consider submitting. Okay, so what's the motivation for the intersection exploration of blockchain, Internet of Things, and IoT? So it has a lot to do with this so-called machine to everything economy. And this is work I did with a former PhD student of mine called Benjamin Lading, who's now a professor in Germany, thesis under my co-supervision to University of Machine to Everything Economy. Oh. Oops. Yeah, smart devices, software agents, and physical systems. So the corresponding ecosystem is formed by automated, globally available, heterogeneous socio-technical e-governance systems with loosely coupled peer-to-peer resembling network structures, and is characterized by its dynamic, continuously changing, interoperable, open and distributed network nature, and thereby the M2X economy employs concepts such as, for example, cyber-physical systems, Internet of Things, and wireless sensor networks. Yeah, so this paper is open access, And I would encourage the audience to take a look at it. If you just type in the title, you will find the paper. Yes, and that is the framework based on which we will move now into the exploration of the elements. So what is IoT? That's the Internet of Things. So with IoT, we build a bridge between the digital and the physical worlds with very little or no human interventions. And the IoT functionalities can be, for example, smart sensor-laden devices that autonomously exchange data across the internet. So they're receiving and transmitting the data to different devices, IoT devices or non-IoT, and that allows for more than one device to be connected with each other. And so these devices create real-time linkages, yeah? And this is a big business opportunity that's opening up many new markets. So we have the forecast of 55 billion IoT devices by 2025, which is quite a progression from the 9 billion we had in 2017. And that yields a nearly $15 trillion US, or at this point almost the same in euros, market in aggregate IoT investments between 2017 and 2025. So a very big market with many opportunities. This has the potential to improve our lives, yeah? For example, monitoring health, patients, energy use optimization, and so on. But there are significant problems of IoT that should not be alien to many of you. So on the one hand side, we have billions of transactions per device, so that creates a lot of latency. And also because we have many IoT producers, there's a lack of standards that we have to observe. And also these devices have low computing power and data storage. Also the network connectivity is problematic. In addition, we have security and privacy problems, for example, with Amazon's Alexa. That's spying on conversation. So if the slides can be made available to the audience, so I have always provided here links, yeah, that you can click for some articles, popular articles in this case, showing you there are problems with Alexa spying on you. Other examples are with security problems that we have hackable heart pacemakers. That's very inconvenient. Hackable security cameras, hacked baby monitors. So with all these issues, 2/3 of consumers think IoT devices are basically creepy, yeah, because there's a lack of security. The other problem is that currently IoT systems are following an architecture that is centralized. So that means only the identified and verified devices are connecting through cloud services that have a high data storage capability. I mean, the clouds, yeah. That also incurs high maintenance costs and extra infrastructure that needs to be added on top. So basically all this cloud infrastructure with the best IoT solutions in addition. So if a number of IoT devices is interconnected at a time, we see the number of communication channels, communication increase, and that leads to economic scalability engineering issues. So if these issues go beyond a certain limit where we have a disruption, then consequently of cloud services that occur, leading to security issues. So the solution lies potentially in decentralized networks. So going to blockchains, I would assume here I can skip quite a bit because we have a very blockchain heavy conference, but I'll just go through this rather quickly given the time. Blockchains can be used then to build to underpin and authenticate cryptocurrency transactions. I mean, we know this initially from the Bitcoin white paper, which has flourished into many different applications and directions beyond smart contracts to dApps and so on. At this point, many businesses, researchers, and customers accept ever more crypto technology, blockchain technology. So the popularity of blockchain is set to increase up to $20 billion by 2024. and 15% it's forecast of banks will soon adopt blockchain to overcome security issues. And at this point, we also have very serious blockchain initiatives, so, like EPSI, the European blockchain infrastructure, and so on. So that's very different to, say, 2016, where if you tried to work in blockchain, that was still considered dubious, but we've gone certainly now very much mainstream. So blockchain, we know, is a cryptographically secured, immutable distributed ledger technology with strong public-private key cryptography, encryption, and cryptography are the very essence of blockchain technology. And we use also strong cryptographic hashing. So it's potentially very secure and decentralized technology. So the Bitcoin paper, very easy to find, came out in 2008. So by no means brand new technology. And even the technology in the Bitcoin paper is old. The novelty in Bitcoin in 2008 was basically how old technology was combined in a very ingenious way to solve many problems like double spend problem, Byzantine generals problem, and so on. Here's another screenshot that is taken from the white paper that goes into detail. I mean, it shows how the transactions are hashed, and the point is, saying Bitcoin, you have a pseudonymous system, so it's not fully anonymous, but pseudonymous, which means you have a private key. The public keys, you can generate as many as you want and expose to the public, but you can sign off basically on transactions that use an arbitrary public key with only one way from the private key to the public key. So details I would, since we don't have time, I would recommend please to read the paper. So the approach is in blockchain very decentralized, so we don't require really a third-party presence. That's the idea, that we disintermediate third parties and instead have blockchain as a truth engine with all the technologies I've mentioned before. What is blockchain is glorified, you could say, data structure very simply, where blocks are created in a distributed manner and then linked together based on hashing. And then the blockchain that evolves, that stores the transactions that occur based on, well, in the case of Bitcoin with proof of work, a consensus algorithm, that's then immutably traceable. That means it's unchangeable. Yeah? And the blockchain as such is then replicated to many nodes, which then also creates additional robustness. So this proof of stake that I mentioned before has been criticized for being very energy inefficient. I mean, using a lot of computing power and energy. So among the many alternatives that by now exist, a very prominent one, I think the first real alternative to proof of work is proof of stake, where you stake tokens instead of solving cryptographic riddles in a competitive scenario, and as a result, you don't have all this energy use. Yeah. Yes. So what we then see in addition, after Bitcoin came out, which has been is pseudonymous, is the emergence of the smart contract systems that are very well known, such as Ethereum. So what is there? The idea that on top of the blockchain layer, you have the protocol layer, and there you add basically the smart contract language, which was Solidity in the first version, where proof of work was used for Ethereum. It's now proof of stake in the new version of Ethereum. So here's again the old white paper about Ethereum. That again is open access, so that's the nice idea about blockchain. Everything is open access, and we have then seen a proliferation of many smart contract blockchain systems after Ethereum came out, which is at this point I wouldn't even say the best solution anymore. I mean, there's so many others, the Cardano, Solanas, and thesis and so on. Yeah. One point maybe quickly to mention is that, of course, we have the completely public smart contract systems like Ethereum, and then the more permissioned versions, like the also very well established Hyperledger, and then some shades of gray variations in between. So let's move on to security. This was not hyper quick because I assume the audience has been exposed a lot to blockchain lectures of all sorts already. So let's go to security. If we have an IoT system, allegorically, we can see this a little bit like a castle. Yeah? So the entire castle needs a secured castle wall. And if only one part of the castle wall comes down, then that's already good enough for the enemy to intrude and to take over the castle. Yeah? So the same holds then for an IoT device that is part of a larger IoT system. Every device must be secure. Yeah. If only one device goes down, is hacked or spoofed on or whatever, we got a problem. So a small breach in the security system can already allow hackers to access a whole lot of information. If the data is stored in one location, like we've heard before, IoT systems are centralized architecture, then it's easy for hackers to target. So I've found here this little, double triangle. For people who understand security, the so-called CIA framework is very well known for security, which is confidentiality, which means data is secured to authorized parties. Then we have the integrity, which means that data is trusted, and we have the availability, which means data is accessible when and where needed. And then embedded, we have an inverted triangle with more blockchain-specific concerns of security. On the one hand side, we have non-repudiation, which means the service provides a trusted audit trail, which is perfectly possible in blockchains. Then we have authenticity, which means the components can prove their identity. And then we have privacy, which means a service does not automatically see customer data. And these are, besides the CIA properties, the ANP properties are very desirable properties to secure IoT system, which we can now assure with blockchains in theory. Okay, so after this block where we've looked at the elementary parts, let's move into these intersections of IoT, the data that actually then IoT generates, then blockchain. That's one means to manage this data and how to secure it and everything. Yeah. So when it comes to IoT security, we've seen an increase of security costs to 20% annually by 2020, and that's quite an increase from 1% in 2015. So now we have almost 2024. I would assume we have at least 25%, if not more, that of a budget for IoT system that's spent on security. So we have then there several bottlenecks related to IoT and technical deficiencies like the device autonomy. Device must be integrated into a heterogeneous IoT system. We have virtual identities that are important so that we can authenticate an IoT device is really bona fide to enter a larger system to not pose a security threat. Then we have point-to-point communication that's complex to coordinate and can easily be attacked. And then we have, of course, the data integrity. So it's potentially easy to compromise the data given the architecture of an IoT system. So the security threats for IoT can be, for example, unauthorized physical device access or software attacks, the software that runs in the device or governs the IoT system, for example, viruses and worms, denial of service attacks, man-in-the-middle attacks. We can harness unsecure IoT devices then consequently to create massive also decentralized distributed denial of service attacks. So accessing the data that's being streamed through an IoT network once we have intruded, that's of course something we want to avoid. Another security issue among the many more are impersonation or device spoofing, and for sure, if you check the literature, you will find many additional security issues. So today, the solutions often revolve around identity management and encryption, which means that IoT data protection is needed really throughout the entire device lifecycle. So what we need to look at is an IoT device that, I mean, first the entire system is created, set up for the first time. And then the systems go through, I mean, the entire IoT system changes all the time. Communication channels are assembled and dropped. IoT devices, separate ones, receive updates. Eventually, they are decommissioned, taken out, and replaced with new IoT devices. So this entire IoT system is a constantly evolving creature, you could say. So blockchain could then mitigate problems, like the security problems, providing a framework with automated security and attack prevention. And note, if you have a cloud infrastructure, so this is the first thing. That's the honeypot. That's where all the data is. That's what I want to attack. So in theory, this is a very nice idea. If we look now at this intersection of security and blockchain, so blockchain is fully decentralized. While the centralization architecture of current IoT system, that's the single point of failure. So if I want to knock out an entire IoT system, I try to attack the cloud directly, if that's possible. And then I have access to all the data, and I can take down the entire system. So a secure infrastructure is certainly one that's far from the centralized model we have at the moment. And as I've alluded to already, every centralized network is potentially insecure. So we have users, devices, identity that always have to be private. And all the data that is channeled through all the connection points into the cloud and then relayed to devices on the edge, they have to be fully private, confidential. They have to have integrity, and they must be available. So this is goes back to the CIA triangle that I've shown earlier. Blockchains then potentially solve the generic issue of centralized IoT architectures, and note potentially because there are many problems related to that, which should make every researcher happy. So blockchains complement IoT. If we understand that the blockchain system is something that we could call a trust engine in a trustless collaboration environment, then we can certainly, with the addition of blockchain into an IoT system, create what we could call an Internet of Trusted Things, which potentially conceptually makes a big difference, of course. We can use blockchain to trace and authenticate IoT data and store potentially also IoT data on a blockchain, while we have to understand that a blockchain as such is not a mass data storage. So every IoT node can be registered on a blockchain with an ID, uniquely can identify itself as a device in a universal namespace. And for a device to connect another device, we can use a blockchain ID as a URL. So we can use the IoT device's local blockchain wallet. So every device would have a blockchain wallet to raise an identity request that's sent to the target device, and then the target device uses the blockchain services to validate the signature using the public key of the sender. So that yields a machine-to-machine identity authentication without the need of any centralized arbitrator or service. So which is always tricky. We want to avoid all these centralizations. So now looking at the intersection of blockchain and IoT a bit further, blockchains promise also a standardization across different parts of IoT. So I mentioned earlier that there's so many different producers, there's no standardization or lack, which, by the way, IEEE is working on. We can track millions of connected devices, and the lifecycle tracking of IoT devices becomes possible. So I mentioned, in order to have a high degree of security, we really must understand each device in its life cycle, from inception when it enters an existing IoT system to its changes as it connects with different devices over time, and then to the eventual decommissioning. So we have then a list of history of connected equipment, all trackable on chain. and we can thereby also coordinate much better between the devices. We then yield as such a decentralized IoT system with trust, where the nodes reach a consensus to approve transactions. So the blockchains then coordinate the transaction layer of an IoT ecosystem and not some centralized honeypot single point of failure cloud anymore. This potentially solves the problems in IoT security also, which are scalability and privacy and confidence, if we stick to the currently practiced centralized IoT architecture model. But so this is now what blockchain in principle promises. However, there are many problems, which gives a lot of room for research work and so on and innovation. The problems for IoT systems are for using blockchains is that we have a huge amount of data processing that occurs. So the IoT systems generate unspeakable amounts of data. Also, we have latency due to blockchain. So anyone who's worked with Bitcoin knows that it's a very slow system. So the ledger replication introduces latency. Acquiring a block may consume extra time, and it's not acceptable in a near-time and real-time service situation. So potentially at this point, blockchain is not necessarily the best suited solution for recording raw data at the source. We also have blockchain scalability issues when the ledger size may lead to centralization again. Remember that each device has very limited capacity. Also, IoT devices have very limited processing time and also, well, electrical power time. And so there's a time hurdle, certainly with the processing power, and we have storage issues. So if we perform encryption algorithms for all the objects involved, that's problematic. And the devices may also have different computing capabilities and run really in a heterogeneous system, because they come from different producers. So not all of these devices will be capable to run the same systems. And also we have low storage capacity, and most IoT devices can't store many blocks. So we have to do something which is called probably sharding, which I can't get too much into. But in a nutshell, the idea would be to just relay parts or shards of the overall blockchain to the devices to unload them to process within a certain context, and then offload that and unload the next shard for the next processing event at the device. So if we now look at IoT data and blockchain in the intersection, there's this well-known CRUD framework: create, read, update, or delete. So these are operations on IoT data that can be registered as transaction records on a blockchain block, and that is good for coordination, governance, and also for auditing in case some security issues occur. The blockchain identity allows to control access control the access management, monitor the information collected by sensors. It yields greater transparency and potential convenience. We can store data in chains of transactions to prevent data modification when verified by authentication systems. So once the data is stored on chain, it becomes immutably traceable, and we can disallow data duplication by any wrong data. So no third party is necessarily required anymore to get involved for data transfer between IoT devices, which can now transfer peer-to-peer instead. So blockchains potentially enable a resilient IoT ecosystem by adopting a standardized point-to-point communication model that comes in through the blockchain use. So we reduce the installation and maintenance cost in big data centers that use clouds. We reduce the storage of IoT devices, prevent errors in nodes that could collapse or be attacked. So blockchains then always replicate and restore themselves to the sound state. And the blockchains record transactions or digital interactions securely. So each block registers the operations with a timestamp. And with the timestamp, we can verify that there's a correct sequencing of the events without manipulation. So we can then assure that we're safe, auditable, transparent, potentially efficient, and interruption resistant. So that way, since also everything is hashed, we have then no data leaks as versus centralized IoT systems that are honeypot. Maybe I skip this, but if the audience can get access to the slides, this is some work I've done that is, coming out of this M2X framework I've introduced in the beginning. That's relevant for this intersection of blockchain, IoT, and security. So this is a system I'm working on with funding in the past from NGI onto chain, hopefully with more NGI funding coming in, about is a blockchain system about multi-factor transit self-solvent identity authentication. So very briefly, you can read the paper, which is online, but the point here is that depending on the application context, a single sign-on, with one challenge, identity authentication is not sufficient. Certainly in complex IoT systems, you want to have challenge sets that can be configured depending on the use case. And then these challenges must be responded to. So let's say if one device talks to another device in an e-healthcare setting, the other device must pass maybe 5 configured challenges before a trusted communication channel could be set up. So in e-healthcare, this would be a very different challenge set versus, let's say, Industry 4.0, production, smart production. And I'm working currently on a system that caters in a flexible way for such various M2X economy situations. Yeah, so I can skip this. I think you can read the paper. So let's go to the application cases. We can use blockchains to secure IoT systems to determine product provenance. So that's a very good case for IoT security and blockchains. Let's assume in complex, long supply chains, it's easy to forge products, so-called counterfeits that are sold to unsuspecting consumers. Instead, we can track the integrity of food or baby formula, where there were scandals with toxic baby formula, wine, and so on. So we can microchip embedded labels that are stored on chain, and then track the life cycle of products that starts from the moment of production through the entire supply chain, goes to the point of sale and reaches out during the final consumer purchase. So it's all stored on chain in a pseudonymous way. And by storing the data on the blockchain, the product details cannot be forged, and we ensure the integrity of the end product. So yeah, I'm wrapping up already. I'm just going through some application cases, and then I'll show you some ongoing research. So here are some papers. Again, if you can get access to the slides, you can then read these papers yourself. So here's about e-healthcare, where blockchains are very good. So certainly here you have also a data logistics problem. Yeah, let's say you have different clinics for complex health matters that need to do diagnosis and then share in a secured way between the clinics data for some high quality diagnostics. Here's an example I found of counterfeiting. So Australians like cricket and rugby. They like to buy these jerseys, and so they can be counterfeit. Many of them are produced somewhere in Asia, and whoever has been in Asia also, you will be aware of the many markets where you have counterfeit products. So if you pay for a product, say in an Australian shop, some rugby jersey, you want to make sure that's original. Another use case is here for facility management, commercial real estate, where blockchains can be used to manage smart office space. Yeah. Here is a paper about the blockchain technology use in the energy sector to make the sharing and storing and trading of energy more efficient and effective. And also dug a little bit into ongoing research results. So here we have a paper, just to prove that this is really a very interesting research domain. And as I said, in principle, blockchains are very useful, yeah, but there's still many issues open for us to fix. So here we have a paper about blockchain-centric IoT architecture for effective smart contract-based management of IoT data communication. So this is really at the very intersection. So this is, as you see, an open access paper. Here's the link provided. Here's another paper about IoT data sharing, an IoT data sharing platform in a Web3 context using blockchain technology. So very briefly, what's the difference between Web 2 and Web 3? Web 2 is what we have now with these platforms, the Facebooks and so on, Instagrams and so on. In Web 3, we have our crypto wallets introduced, plus also self-sovereign identity authentication so that users can regain ownership and authority over their own data sets again, which is currently not the case because data which we put out into the public is traded very liberally by the big tech platforms without our knowledge. Here's another paper I found about enhancing security for healthcare documents in IoT-enabled digital healthcare ecosystems using blockchain. So healthcare definitely a very nice application scenario. Also in agriculture, which has been a bit under well, not paid attention to so much by automation, but we're moving into a world of also smart agriculture. So also there, agricultural is a paper about agricultural IoT data storage optimization and information security methods based on blockchains. Yeah, so another use case. So these are all machine to everything economy cases. Yeah, so as you can see, very exciting fields where many researchers and also students who maybe want to do a master thesis can get into, yeah, many opportunities also to make money business-wise. So to conclude the presentation, give you conclusions, limitations, open issues, and future work. We see that IoT systems with centralized architectures are a single point of failure. And instead, we have these conceptual security properties that exist. So that's the traditional confidentiality, integrity, and availability. But now with the addition of blockchains, privacy, authentication, and non-repudiation, we can use blockchain technology for a framework that secures IoT systems for large data management. But that's the exciting part. We have many limitations, open issues, and future work. So the current performance and scalability of IoT are incompatible with blockchain functions. Yeah. We need new types of blockchains. I gave you some papers that show this is already work in progress by universities and industries and these novel blockchain systems are needed for the predicted 55 billion connected IoT devices, and that's only the beginning. So these billions will increase very sharply. We have also a need for novel consensus and validation algorithms beyond proof of work, which is completely impossible in this case. Also proof of stake only to limited degree. Okay, we need a lot of work on novel consensus and validation algorithms for IoT peer-to-peer communication. So the IoT platforms are a massive source of raw data that they generate. And so, yeah, we need to combine and understand the unstructured data, extract intelligence, advanced analytics, extract actionable intelligence for decision making. So that leads quite a bit to AI as an option, but of course also with artificial intelligence, machine learning, and so on, that we can then use on these large data sets that IoT systems create. If we cannot trust the source of the data, yeah. There's no confidentiality, then it ends up being garbage in to say AI analytics or machine learning analytics, and then it's garbage out. So that's not working. But we really need blockchain so that we can do provenance tracking, yeah, to assure that the data sets are of high quality that can be trusted. Then it's not garbage in and garbage out, but quality data into the AI machine learning and quality data coming out. Yes, thank you for your for paying attention, and I'm ready for Q&A. Thank you so much.
Thanks, Alex. One question for me, and then I will receive the question from the audience.
Yes.
Can you quickly flesh out the difference between centralized identity and decentralized identity, and what are the differences, and what are the like main structural advantages and disadvantages of classical centralized identity systems and decentralized identity systems?
Yeah, I mean, certainly since the COVID times, what we've seen, centralized systems. I mean, let's go away just from the technicalities, but from what users really experience. Yeah, so if you have a centralized systems that say is run by one single sovereign, as long as the sovereign is nice and kind to the public, that's all fine. But the question is what is attached, yeah, all sorts of credit scores potentially, or maybe carbon credit tracking and so on. And let's say you have a bad social credit score, then very quickly you can find yourselves being partially or entirely excluded from services, even private services, if one sovereign manages a single sign-on centralized ID system. Yeah, so this is very problematic. You have to trust the sovereign, and as history shows, sadly, sovereigns over time tend to go rogue, and we definitely would like to retain the liberties and freedoms of citizens, some sort of self-sovereignty, and in that sense, decentralized, preferably also multi-challenge sets. Identity authentication systems are preferable that are really peer-to-peer, yeah, and where the sovereign is either not involved at all or to a very limited degree, depending on what the preferences are. But again, all extremes maybe are problematic. Yeah. So okay, that's a personal choice. I believe in the sovereignty of individual citizens. So in that sense, at least my personal preference is to have, well, decentralized self-sovereign identity authentication based with multi-challenge sets that need to be satisfied by correct responses. And but yeah, I mean, the preferences may change, but I think for most people, it's a very scary prospect if you have one sovereign, let's say one government controlling for all the citizens an ID system, and that can potentially lead to the exclusion of large parts of the population from services. Yeah, thank you.
Thanks. One question from the audience.
Hello.
Yes, hello.
I want to ask about scalability.
Yes.
As we know, Internet of Things will generate a tremendous amount of transactions, and I was wondering if the current blockchain can handle it, or if there is anything that's...
I mean, so what we have are acyclic directed graph solutions like IOTA, yeah, that lend itself. That's one alternative. So as I said, blockchain. I mean, blockchain. Yeah, you have smart contracts. You have the blockchain ledger as such. You have the also when you think about further, a bit further, I introduced in the beginning this framework of the machine to everything economy, so M2X economy, so that hints at payment systems. Yeah, so you need fast, suitable payment mechanisms. So crypto payments would be good. In you need the token economies. Yeah, so you get all of that with blockchains, but certainly scalability is problematic. So that's why I said I present to you blockchain as a theoretically very wonderful solution, yeah, for securing IoT data, and also what I didn't go so much into here, making this commercially viable, yeah, with a very fitting, tailored token economy. But as I've also hinted at in the presentation, scalability is definitely a problem. On the one hand side, the scalability of the blockchains themselves. So that's why we see so many papers that are being produced now about solving this issue, yeah, and also the devices as such they are not scalable because they have, I mean, very limited capacities and so on. So many exciting problems. We definitely have scalability issues. Yeah? Certainly as the number of IoT systems in use explodes, as the presentation hopefully has made clear. So yeah, not currently we do have problems in scalability, but that's the exciting part for researchers and innovative companies to take a look at that, how to resolve that. Thank you.
Thanks.
I will ask another question. I don't know if it has anything to do with this, but how will next generation computers, I'm talking about quantum computers, affect this?
Yeah, I mean, of course, we have the problem that quantum computers can hack the cryptography. Yeah. There also, this is something that has to be taken into consideration. Very recently, with IEEE, I looked at a presentation about quantum resistance or being quantum proof. So in the sense that you have devices and software and systems and cryptographic algorithms that cannot be hacked by quantum computers. Solutions already exist, what I've heard. In the presentation, this IEEE presentation from a professor, a female professor, I've forgotten her name. But this is, of course, very heavily looked at already. So at this point, not so much of a concern, yeah, but it's predictable that quantum computers will definitely reach a maturity where, you know, the cryptography that we have at the moment is under threat. And then we got a big problem, yeah, if we don't fix the algorithms to become quantum proof, yeah. But as I said, this has been recognized already many years ago. So I remember back in 2017, I came across the first, well, I think 2017, I came across the first papers that started looking into this. And right now, what I observed in this very recent IEEE security lecture I listened to online, it's something we can tackle. Yeah, we can assure to be quantum computer proof resistant, but of course it requires many updates, yeah, of certainly of the cryptography. We require new algorithms to be safe. Yes, thank you.
I will ask another question about the same topic. What about the use of quantum computers to accelerate the use of this new technology, the Internet of Things? I mean, we talked about the
IoT. Okay. I mean, okay. So yes, it's a good question. So I'm not a quantum computer expert, but the last time I checked, I saw these mega boxes, you know, that feel, I mean, they're quite bulky things, these quantum computers. Yeah, how to bring them into backup IoT systems, if that's the question you have. I think in that case, we might go, I mean, that hints again at a rather centralized solution, yeah, because we need the quantum computer. Last time I saw one in a photo in some sort of article, I mean, some figure was quite a bulky thing, yeah. So that would hint again at a more centralized approach, yeah, where the IoT devices become the clients. Yeah. That's then the question. Maybe this solves many problems again. Yeah. Certainly with maybe scalability, but more philosophically, the question is then, well, do we trust decentralization? How much do we want to be decentralized? How much do we insist on being decentralized to have self-sovereignty? So when we have the quantum computer box somewhere set up to back up some IoT system, yeah, then again the question is, well, can we trust this one company or again some sort of government, yeah, that runs this quantum computer box or boxes, yeah? Because as a private citizen, well, also a medium-sized company, at least at this point, and I would say even in the predictable future, not so quickly will this be like a quantum computer, like a, I don't know, a mobile phone that I can hold in my pocket, or a little, desktop machine that's quite affordable, but will require a lot of capital and a lot of money to purchase and to maintain. Yeah. So yeah, so I would philosophically prefer to be more decentralized. Yeah. So as long as these boxes are so expensive and also, well, probably tricky to maintain, that would mean we go back to more centralization again if we adopt quantum computers into running IoT systems. So we have to wait for Moore's law to move on until we can have quantum computers in our pockets. Won't happen so quickly, I would assume. Thank you.
Thank you very much.
Thanks. One question. One more question.
Hello, and thanks for interesting lecture. What main benefits of modern blockchain technology would you separate from others?
You mean blockchains? You mean, if I understand the question correctly, so like what are the best blockchains for whatever solutions? Is that what you mean?
Yes.
Okay. Yes, I mean, it depends how you look at things. I mean, Ethereum definitely has the first mover advantage, yeah. But so there's a big ecosystem behind Ethereum. The problem with Ethereum is that it's extremely slow. Yeah, so you can only have a very low number of transactions per whatever period of time per second, if that's how you want to measure it. And if you have many IoT devices, many IoT devices transacting with each other and so on, probably not a good solution. Yeah. So I mean, I know what is now very fast, yeah, and economically, I mean, very economically is Solana. That's been very often in the news lately. But you have this discrepancy. Is another triangle where we want to be decentralized, but we also want to be secure. And what's the third one? So there's this discrepancy between decentralization, scalability. Yes. So, and Solana has been known to not do so well in this respect. So Solana is quite, I mean, it's very scalable. Yes, very scalable. But so it can transact very fast, but for the price of being rather centralized, is my understanding, and also not so secure, or it has been at least, because Solana has a history of crashing quite a bit. So maybe, given the rapid rise recently of the Solana token, that could hint at some maybe technical solutions and innovations where this issue has been fixed. Yeah, maybe. And so there are many applications that use Solana. I would have to look into it, but it could mean, okay, these technical issues that led to many crashes that has been resolved, but still the architecture is quite centralized. Yeah, so this is really the issue that Vitalik Buterin, the most famous developer behind Ethereum, pointed out. You know, scalability, security, and we want to be decentralized. So you really have to look at blockchain system, smart contract blockchain system for this from this angle. There are trade-offs, yeah. And then the question is, what do you tolerate given the application context? Yeah. So I don't think there's the one and only holy grail smart contract system out there. So with my PhD students, I've done many studies in evaluating for different contexts. So if you go a little bit into, say, if you just search me online in my publications, there's some recent systematic literature reviews I've published with my PhD students, looking, from different contexts at the large number of smart contract blockchain systems that we have and try to evaluate them. I think, you really have to take a close look, depending on what you're trying to build, for which application context, for which use case, and then make your smart picks. There are, I mean, some systems, let's say you want to have a smart contract blockchain system with a smart contract language that you can verify with tool support. Maybe Tezos is then a very good candidate that is derived from OCaml, and also Cardano has some smart contract language that's derived from Haskell, if my memory doesn't fail me. So this has been, you know, these are languages which have been studied very extensively in computer science. There's tool support, open access tool support available to then check the code. Yeah. In Solidity, you can't do that. So this is problematic from a security point of view. But then again, say if you choose Ethereum, you have many developers available and a huge ecosystem behind it. Yeah. So it's a complex question. I can't really say which one smart contract blockchain system is the best one, but it really depends on the context and what then the requirements are you need to satisfy. Yeah, thank you.
Thanks, Alex. One final question for me.
Yes.
It's not from the blockchain and IoT, but still it's the most interesting topic, I guess, 2023 about the AI. So, as you know, this grandfather of AI have left the Google, who discovered this neural nets and implemented.
Yes.
He was like telling that now we should regulate the regulate the AI like the atomic weapon, because it's really dangerous and really scary. And
yes,
this kind of messages I'm hearing from the professionals who are working in the field of the AI. And is it real? And plus the fact is that the algorithms inside the black box, if the data becoming too big to process, you can't control the outcome. So you cannot track what kind of decision making process going on inside this black box. Is it really that like we should start bringing the alarm bell and try to somehow like internationally regulate it, or try to go outside a little bit and stop this development and like wait for 10 years and something like that? What is your probable solutions? Are we going like with this like in Pandora box, and we are putting the technology and we don't know what will be the outcome? And I guess
I mean, it's so I mean, yes, of course, I think the genie is out of the box. Yeah, so AI is around, and there are all sorts of developments very hard to control. Can we control this? So there will be probably AI wars, in a sense, and definitely once AI reaches a level where it can actually tune itself, so it doesn't even need humans anymore for training and all this. But we have reached an AI level that is self-propelling, and enhancing, improving itself. Human intervention not needed anymore. This starts to be very interesting. Regulation-wise, this is very tricky. I mean, I think the EU tried now to come out with some regulation. I have to look into it, but there's a lot of unhappiness. What regulations have been issued now? This is brand new, I think, only happened a couple of days ago. And many are now complaining that the AI definition goes way too far. And of course, there's then always the issue, you know, we want to innovate, we want to move on and improve society. This is always with risks, but maybe let's just talk about the EU, you know, has its clientele it caters for, you know, established companies that don't like competition maybe so much. So then the call to regulate AI might then be flanked with these special interest groups, let's call them like this, yes, industry close to Brussels and Strasbourg, who then want to see regulations that give them some quasi-oligopoly, monopolistic almost protection from competition. So I think, and even if we now regulate things, I think rogue rogue AI developers and groups will not care much. They will still develop their AI. So I'm not sure if that makes too much sense to regulate. It might be we shoot ourselves into the foot, yeah, because the rogue elements, they will still do the rogue AI. And then we have all this regulation. So those who could counter the rogue AI, yeah, they are now so stifled they can't do anything anymore, can't counter the rogue AI. So I think the genie is out of the box. I'm not sure if regulation will help also much, but indeed, I think we need to fortify the cryptography, work on securing ourselves. That's definitely an issue that AI may, start hacking systems on the internet. So certainly this connection of AI to the internet, that's been seen as very problematic, I understand, yeah. But that's now already out. I think Google has gone so far, yeah. So the AI is connecting now to the internet. I think regulation will not help much anymore. We just have to see what happens and allow for the countermeasures, yeah, to the rogue AI to be able to also do their work. If we stifle all of that with regulation, then I think that will be the disaster. That's my take on it. But it will be interesting for sure. Yeah.
Yeah. Thanks, Alex, for the wonderful presentation. And
yes,
we're glad to have you here.
Slides. Yeah, share the slides so then people can click on all the hyperlinks.
Sure. Have a good day. Bye.
Yeah, you too in Georgia. Yeah, thank you. Bye-bye.
Bye.
Bye.